Hey guys, so 3.3 is on rate of change and slope. So the goal here is we're going to try to identify what the slope of a line is. Okay, so the slope of a line is really just the rate of change. So that's where we'll start. So the rate of change is just a ratio that describes how much one quantity changes with respect to another. So the rate of change here is the change in one quantity, y, over the change in another quantity, x. So remember, or notice how for this little triangle symbol, I say the word change. It means change. It's actually a Greek letter, delta, but in math it means change. So the change in y over the change in x. If you look at this diagram to the right, this little graph here, okay, we see how that plays out for a line. So this rate of change of the y's and the x's creates the slope or the steepness of our line. Okay, so the slope is just the rate of change of specifically a line. Rate of change could deal with other things besides a line, like speed and things like that. But on a graph, on a line like this, it's called the slope. So the slope is calculated by the rise over the run. We call it the rise over run. You might see slope equals rise over run before. It's also calculated by change in y over change in x. And change of y over change in x, the way that we do that is we do y2 minus y1. So two y coordinates, subtract the difference between two y coordinates over the difference of two x coordinates, or the change in x, which is x2 over x1. Now notice also that m is the variable that we use to calculate slope. Okay, so m means slope. And this y2, y1, x2, x1 actually come from this graph up here. Okay, they are our points on the line. Okay, so the change in y is the rise, and the change in x is the run, the side-to-side change. All right, scan these four types of slope, right, just so you can see what they really look like. Okay, so it just might help you to see that something that falls down to the right is going to have a negative slope. Something that's going to climb up as you go to the right is going to have a positive slope. Okay, so anything that looks like this, it looks like that, or this, or that, right? All of that would be negative slopes. Positive slopes would be all of anything that looks like that, right? Anything that's climbing to the right. Now, something that's straight up and down, a vertical line has an undefined slope, and a horizontal line has zero slope. Not no slope, but change it to slope equals 0. Okay. Now, just a quick review on how to do these lines. Right, if we were going to write the equation of that line right there in red, remember that a horizontal line is a y equals graph without an x in it. So y equals, you're up 2 there, so y equals 2. And a vertical line is an x equals graph. So this is going to be x equals, you're left 2, so x equals negative 2. So we're going to use this table to find the rate of change, and then we're going to explain what that means. Okay, so the rate of change basically is going to, these are giving you points. Okay, so these 3 points, you've got 2, 76, right? So this is like x1, it's like y1. This is another point here, x2, y2. And this is another point, we have a third one, x3 and y3. Okay, so in order to find the rate of change, you just find the change in y over the change in x. You don't have to find between all 3 points, just pick any 2 and just be consistent. So the rate of change here is going to be y2, we'll just use y2 minus y1 over x2 minus x1. Okay, so y2 is 152, y1 is 76, x2 is 4, x1 is 2. Then we do our subtraction. We've got the rate of change equals 76 over 2, which reduces down to 38. Okay, so what that means, right, quickly, is that it's y is miles and time driving is hours. So in order to find the meaning, all you have to do is write these, change in y, remember, is on top of our fraction, miles, and change in x is our denominator. So what that means is 38 miles per hour, right? Or you could use mph, obviously, for miles per hour. So that's just giving you the speed that you're traveling. All right, now find the slope of each line. Okay, so we've got 3 lines here. we'll start with the blue one. The best way to do this is just to count. You don't need to do any calculation. When you're just reading from a graph, you just find 2 points that are very obvious. So in the blue one, we're going to use the origin there, and we're going to use this point right here, right? 0.12. Okay, now the way to calculate it is the rise over the run. So you figure out how far you're going up and how far you're going over. So you're going up 1 there, and you're going to the right 2. Okay, so the slope of that line is 1 over 2. Remember that to the right is the positive x direction. Now for the red one, I see this point again, and this point right here are the two we're just going to count between, the rise over the run. Now remember what it looks like. So this one looks like this. You're climbing as you go to the right, so you know it's going to be a positive looking slope. Alright, so you're going to go up 2 and to the right 1. So that's going to be 2 over 1, which is just 2. 2 over 1 is the same as 2. You guys know that. And lastly, this last one, the green one, this one's falling to the right. It's going down as it goes to the right. So it's going to be a negative slope. Once again, we pick 2 points. This one, this one. You're going to go down 2 and to the right 1. Remember, down 2 is negative. So this is going to be a negative 2 over 1, which is just negative 2. Now to figure out if these are linear, all you have to do is kind of count step by step as they go through and figure out what the change is in the x's and what the change is in the y's. Alright, so for the x's, we're adding 1 between all of these. Okay, and between 6 and 12, we're adding 6. Between 12 and 18, we're adding 6. Between 18 and 24, we're adding 6. So they are, the rate of change is not changing. That's what a linear equation looks like, right? The rate of change stays the same the whole time. It's constant rate of change. Okay, so that is a linear function. This other one, figure out the change in our x's. We're going to add 8, add 8, add 8. And the change in these y's, we've got minus 4 for the first one, minus 5 for the second one, minus 6 for the third one. So see how on the right they're all the same, but on the left the changes aren't all the same. So the rate of change is not changing, or is not staying the same, so this is not going to be a linear function. Now to find the slope of lines that pass through points, we have to use our equation, our slope equation. Okay, so the equation, remember, is x1, or y2 minus y1 over x2 minus x1. So I label my points, or at least for the first couple times until you can see it for yourself without trying to write it out. Alright, so m equals y2, 5, minus y1, 2, over x2 is 5, minus x1, which is negative 3. Okay, so we have 5 minus 2 is 3, and 5 minus negative 3 is the same as 5 plus 3, which is 8. So the answer is 3/8. And B, we've got the same idea. I'm not going to label them anymore. If you would like to label these, the points as x1, y1, and x2, y2, that'd be great. If you don't need to, that's not a problem. So we've got y2 is negative 8, minus negative 4, which is the same as plus 4, over negative 2 minus negative 3, which is the same as plus 3. So we have negative 4 on top and 1 on bottom, which is the same as negative 4. And C, y2 is 4, y2 is 4, y1 is 4, x2 is 4, and x1 is negative 3, so it's going to be plus 3. So 4 minus 4 is 0, 4 plus 3 is 7. Now, if you have 0 on top on the numerator, okay, then the answer is just 0. Right? And we'll see what happens when the 0 is in the denominator on the next one. So for D here, we've got the slope equals negative 1 minus 1 over negative 3 plus 3. Negative 2 on top, 0 on bottom. Now you have a 0 in the denominator. You cannot have a 0 in the denominator. This is a problem. Okay, so the actual answer for this is undefined, or no slope. Now this last problem here, we're going to try to find the value of r so that the line that goes through 6, 3, and r2 has a slope of 1/2. So we're going to use the same equation, m equals y2 minus y1 over x2 minus x1. This is x1, that's y1, x2, y2. And, of course, we have the m right there. It's 1/2. Okay, so we have everything that we need here. So we're just going to plug all these things in. So 1/2 goes in for m, y2 is 2, y1 is 3, x2 is r, x1 is 6. Okay, let's simplify this a little bit. So we've got 1/2 equals -1 over r minus 6. Now we've seen problems like this before back in chapter 2 when we did proportions. Okay, so remember for all proportions you cross multiply. Okay, so cross multiply, so we've got 1 times r minus 6 equals -1 times 2. Okay, so 1 times r minus 6 is just r minus 6, and -1 times 2 is -2. So we have to add 6 to both sides to find r, and we get r equals 4. That's it.